morning, everybody. Welcome to the day 3 of FDP program. Today we have Dr. Ilai Kavati sir, Assistant Professor, Department of CSE from NIT Warangal. Sir received his BTech and MTech from JNT Hyderabad and PhD from University of Hyderabad. He also received RDI Fellowship for pursuing his PhD. Sir is also a member of elite institutions such as IEEE, ACM, ISTE, and many more. He has more than 50 publications in various journals and conferences. Sir also visited countries like Singapore, Malaysia, Saudi Arabia for presenting his research. He also has 13 years of experience in teaching and 5 years of experience in research. Sir, we welcome you to KLEF. The time is all yours, sir. Thank you.
Is required. Mic is required. Okay, fine. So, very good morning all. support systems for autonomous vehicles. Deep learning. So whatever may be the learning, like learning or machine learning. But I'm going to cover like what are the important things in autonomous vehicles and some works we did like so whatever the works we did in our my students, actually my PhD student currently working on this particular problem, right? So what is an autonomous car or self-driving car? You know, self-driving vehicle, autonomous vehicle means driverless, correct? But you know, what are the challenges associated with that? Driverless vehicles. You know, because as a human, as a driver, suppose human will be there, so he can sense the environment. So while driving, so you can observe or you can sense like what exactly there in front of that particular vehicle, right? Whether that is a pothole or any obstacle like any object is there, right? Or any animal is there, or any animal is approaching our car while driving, and signboards. So what speed we have to maintain, correct or not? So signboards and everything. We can, as a driver, as a human will sense everything. But you know, for autonomous vehicle, that is self-driving cars, so that there is a need of an intelligent system, correct? Intelligent system that could sense the environment, and based on that, it has to based on that, the intelligent system has to follow the process, driving process, correct or not? But as a human, we can sense how the intelligent system will respond to that thing. So here in this particular topic, I'm going to cover few of the challenges for self-driving cars and how to address them. Okay. So different names can call like autonomous vehicle, AV, right? A connected and autonomous vehicle. CAV, connected and autonomous vehicle means what? What is meant by connected? What is meant by connected? Vehicle to vehicle communication. They are connected with other vehicles, because you know, suppose in some place there is a traffic jam. There is a traffic jam. So how that information will pass to other vehicles, right? So they should be connected. Like us, we have a group and we can chat, right? Like where are you? I am here. Tomorrow class here or not? So like that. So here also there is a connected vehicles will be there, right? A driverless car, a robot car, right? So it is a vehicle that is capable of sensing its environment and moving safely with little or no human input. With little or no human input. Okay? So there are actually five levels of autonomous driving there. Now we are at stage 3. You can see the early levels. 5 levels of automated driving. So still the research is at level 3. So now we will see what is different levels. So level 1, you can see hands-on. Level 1 is hands-on. What is the meaning of hands-on? Hands there on the steering. Hands there on the steering, and legs will be there on the accelerator as well as brake and clutch. Right? So this is no way an autonomous vehicle. Completely driver means driver will be there. Right? So driver is completely responsible for controlling the vehicle. So this is simple. Our whatever system currently is there, that is level 1. No autonomous, no intelligence. Driver will be there. Now coming to level 2. Hands off. Hands off means oversteering, the hands will not be there. Means driver is there on the seat, but he will not control the steering. He will not control the steering. Right? So here, so driver must monitor the driving and to be prepared to intervene at any time. Example, brake automatically, accelerate, take over steering means not fully automated, just some intelligence is introduced, right? But in case of any emergency, the driver must take the steering. Starting stage, right? Now coming to level 3, eyes off. Means In the level 1, only hands off. Hands off means he will monitor the situation, right? Process. Okay. But in the level 3, eyes off means you can relax by closing his eyes and you can simply sit in the vehicle. But again, in case of some emergency, brake failure or some situations, he has to take control. So the driver must be ready to intervene within a certain time frame after a warning. Suppose if something is going to happen, like let's say, suppose the system, some brake failure, or the system unable to identify a particular situation, like some animal is there, or some what is that zebra, not zebra cross, speed breakers. So in that situation, so some warning will be there. Again, he has to take control and he has to apply the brake or whatever that thing. Now the research was at this particular point means completely means was there in some Dubai, recently Dubai, who is the king? Sheikh someone. Okay. So it is there, but some companies, Tesla. Okay. Now coming level 4, mind off. What is mind off? Similar to level 3, but no attention is required for safety. Okay? So similar to level 3, mind off means you can completely relax, right? So here driver intervention, you can see here. No driver intervention is required. So semi-automatic means case of some emergency, using some remote method, you can apply some braking or kind of thing. And coming to level 5, this is fully automated. Steering wheel optional. There is no steering also. The system itself will drive safely. Okay. So these are the different levels of autonomous driving. Now, but at we are level 3. So you have to do like level 4 and level 5. Okay. You have to apply your intelligence to make a automated system. Okay. Such that that is fully automatic. Right. Now, what are the different challenges? Basically for Indian roads, what are the different challenges? The main challenge is what? Road conditions. Road conditions. Correct or not? Wherever you go, there will be no potholes. There will be damage. Correct or not? Yeah, please. Hello. So, in Indian roads, we can observe a lot of potholes. Means gauge road conditions. The main first important thing is road conditions. And the second challenge is that know about other vehicles on the road. Right? The automatic vehicle, self-driving car should know what other vehicles are there on the road. Right? And it has to know the traffic rules. As a human, we know what is red color, traffic light, and what is green, and what is one more? Yellow. Right? So red means we have to stop, green means we have to start. Sorry, we have to. Yellow means orange, sorry, not yellow, orange. Right? Right. So this is also important. As a human, we know that. But how the machine will know, right? So we have to train the model. We have to train the model, the machine such that it has to understand the traffic rules. Not only traffic lights, traffic signs. Take left, take right. There will be hundreds of signs. Slow down, 30 kilometers per hour, 20 km, 60 km, 100 km, 120 km on the ring road, right? So all these conditions it has to learn, it has to train, right? So that is important thing. And know about any obstruction on the road. Obstruction means suddenly, this ring road is okay, but if you go on such roads, suddenly a dog will come. Suddenly a dog will enter into the road. So what you need to do as a human, you will apply the brake, but machine within short time it has to respond. Within short time it has to respond. Okay? So that's why these are the different support systems needed for autonomous vehicle. So in our work, actually we started working on potholes and other vehicles and traffic rules as well as any obstruction. Any animal is there or any animal is approaching the road or leaving the road, so that the vehicle has to take the appropriate action. Okay. So we are going to discuss. We are going to see these different frameworks here. The first one is lane detection. First and foremost, important thing is, because on the ring road there are 4 or 6 lanes are there. 4 lanes, 6 lanes, 4 lanes, depends on. But first we need to identify the lane, on which lane it has to go. On which lane it has to go, right? Then the second framework, traffic light detection and timer. The counter detection. Why it is important? Counter. Suppose there is a red light, means it has to wait, vehicle has to wait. But how much time? The counter value is also important. Okay? So that is vehicle accident detection. Suppose on the road while the vehicle is going on, suddenly some vehicle may be there. So we need to identify whether there is any chance of accident with that, collide with that vehicle or not. Okay? So if there is a chance of collide, again we need to apply the necessary action. What is action? Apply the brake or slow down the vehicle. Right? So next one is the pothole detection. The last one is pothole detection. Right? So lane detection, these are the steps. So okay. Anyway, just listen to the concepts. I will discuss in general way. I think you don't know image processing. You don't know MLDL, right? You know MLDL? But okay. Anyway, these are basic concepts only. I will let you know, like where you get the code, from where how you will identify a problem statement for your project, like that. We will continue. Right. So the first thing is lane detection. You can see that is a image. That is an image, right? The image A is there. So there is a dashboard camera in front of the car. So it can take the picture of that road in front of that particular vehicle. Correct or not? So how will you see here? My vehicle is moving on, means driverless. Means driver is not there. But in front of my car, there is a camera, right? So that camera will take the video of the road. Correct or not? So that based on that video, now it need to identify on which lane it is going, and while suppose a vehicle is there in that particular lane, it has to switch the other lane, right? So this is the image captured. Now let's say the first step is take the input frame. Input frame means take the input image. The second one, the image B, that we are making the image into a blurred image. Blur means to make it more apparent, more to add some more visibility. That means it will increase the contrast of the image. Contrast means quality of the image. Okay. So that is the second one. And the third one is the third step in lane detection is what we are doing here. We are applying edge detection method. What is edge detection? Suppose take my photo. The edge detection what it will do. Suppose let's say it will start from the top left of the image, and it will try to identify sudden intensity changes. So how the edge detection algorithm will work? It will work based on the sudden intensity changes, sudden brightness changes. Suppose let's say it is coming like this. Now whenever it touches my hair, the scanning algorithm touches my hair, so the background may be some color, but suddenly some gray or black color will change. Means there is a sudden change in the intensity. So that thing it will identify and it will make it as an edge. Make it as an edge. Now suppose after that, whenever it crosses my hair and touch my forehead, again there is a sudden intensity change. Correct or not? Gray to some color, right? Now once this part is over, and again whenever scans from here, suddenly this part will comes, right? So again there is an intensity change, right? From here also. So like this, the edges will be identified. Now if you the algorithm once it comes across my shirt, again the sudden change in the color. So if you observe the first image, this is the sky color. What is the color? Let's say that is blue. That is blue. Correct or not? Now the algorithm scans like this from top left. Here there is no change. So that's why you can see complete black is there. Complete black is there. Once touches this trees, there is a sudden intensity change. What is this intensity? Green. Blue to green. Sudden intensity change that we have to identify as an edge. That will identify as edge. So these particular points will be now marked. You can see here. These particular points will be marked. Right? Now coming across here, up to this is okay. But now coming to this is the road is in black color. Road is in black. Right? Now zebra lines. The lane color. What is the lane color? Zebra lines. White. So you can see there is a sudden intensity change from black to white because the scanning algorithm works like this horizontally. Scanning algorithm works horizontally. Or it also can work vertical also. That is depends on our intention, our requirement. Okay. So based on the filter, horizontal filters will be there, vertical filters will be there, right? So here I am applying horizontal. Now there is a sudden change. So these will be marked. You can see here. Again, there is a sudden change in the intensity. So these will be marked. Right? So like that, now we are able to get the what? Edges of the images. So the edges also includes our lines, lane lines. Correct? Now the next step is masking. The next step is masking. Right? D. Step D is masking. What is meant by mask? Covering. So masking will convert. Okay. So this is just like an AND operation with zero. AND operation 0. What is the result? Any intensity into 0. What is the into 0? 0 means black. Okay. So in image processing, in any image, there are three types of images actually. Black and white. TV, black and white TV, you know. What colors can get there? Either black or white. Then what is the next? Grayscale. So grayscale there are, in black and white there are only two intensities. Either 0 stands for black, 1 stands for white. Okay, that means 0 up to 255. 255 stands for white. But in grayscale, there are intensities starting from 0 to 255. 0 to 255. So 0 means complete black, 1 means black only, but different intensity level. 2, 3, 4, 5, 6, 7, 8, 9, 100, 101, 102, like that up to 255. Up to 255. Now 0 is black, 255 is white. So what about this 1 to 254 then? 1 to 254. So they are intensities. Means as the intensity value is increasing, the white content in the pixel increases. as the value is decreasing, it is moving towards black. So between black and white, that many levels will be there, intensity levels will be there. Okay, so total 256 intensities will be there. Now here color again. So what about color then? Color image. Black and white is 0, 1. 0 or 1, that is white. Black or white. Grayscale is 0 to 255. And color is, there are three different RGB. Red, green and blue. So again the red content, the mixing of red, green and blue at various intensities will create a color picture, color image. Okay. So now the red intensity either 0 to 255. So 0 means complete black. 255 means complete red. R. Sir, any marker? So, in computer graphics subject or computer graphics will be there for you in third year or second year. Okay. So in there you'll know like what is RGB image. Right. Okay. So we have here R content will be there, green content will be there, blue content will be there. Now tell me with grayscale how many intensities are possible? 256 intensities. So you have to answer for this question. Hello please. So in black and white we have only two intensities, either black or white. In grayscale we have 256 intensities. 256 intensities, like 0 to 255. Black to white in between those. Now RGB. R variants. Again from 0 to 255. Green also. Green combination 0 to 255. Blue combination 0 to 255. Now how many total combinations will be there? How many colors are possible? See, I am mixing R very small, red very small, green full green, blue medium. Some color will get. You know, Rangoli. Okay. Red, green, blue mixing at various composition. So, 255 red variants are there, 256 green is there, 256 blue variants are there. So, if we mix this red, green, blue in different proportions, how many color combinations are possible? 256 into how many colors? Millions of colors are possible. Millions of colors are possible. So while Rangoli, like Ulu, Telugu. So we'll mix na. We'll mix that red, green, blue or some other color. So by these colors, mixing these different colors, we get produce another color, right? So that many millions of colors are possible. So that is called color image. That is called color image, right? Now coming to our masking. So what is the purpose of masking here? What is masking I am saying? Performing under operation with 0. Under operation with black color. Black means 0. Right? Now anything multiplied with 0 will get 0. 0 means black. 0 means black. So if you observe here in the camera, so above part, this part is required for us. This part is required for us. Not required. What is our purpose here? Lane detection. Only lane detection, right or not? So the upper part, what is the sky and the trees? Okay? So that's why we need to mask out. We need to ignore the upper part. So to ignore the upper part, multiplying that upper part with 0. With 0. Now this part we are ignored. This part we are ignored. Only now we are able to see the lanes. Correct? Now the next step is, but if you observe here, the lanes, okay. If you observe here, in this particular observed lane, there are discontinuities. discontinuities. Correct or not? There are discontinuities. Okay. So the next step, what we will do, we make the line as a continuous line. So using Hopf transformation, so this is an image processing technique to transform the pixel dots. To transform the pixel. I'll ask the questions. I'll ask questions in between. Okay. From the topic covered. So what edge detection method we used in the previous step? Can edge detection. Okay, note that points. In between, I'll ask the questions. Right. Can edge detection method. So what is the purpose of that? To identify the edges in the image. Edges. This is an edge. This is an edge. This is an edge. This is an edge. Right? This is an edge. This one is an edge. This one is an edge. Right? So sudden changes in the intensities will be identified by the edge detection algorithm. Right? CANY. CANNY. Right. Next. Now there are some dotted pixels. Means there are some continuities in the lanes. So to make it continuous, here again we are using Hopf transformation. Okay. Hopf transformation, what it will do? It will fill the gaps. Fill the gaps in the just to understandable lines, right? So this is a image E is the continuous lines, right? Now the next step is overlap this image E over the highway image, like original A. This image, the image A. So if you overlap that one, now you can see there is a filled continuous lines, right? Now the next step is, so locate the most dominant lines by taking the longest lines in the left and the right slopes individually. So among that, take the longest lines as the lane lines. Okay. So the final step is calculate the smoothing moving average and identify locations on the lines to get the final mark. So now you are able to get the final lanes. So this is one method, simple method. So what method we use here? CANY and Hopf transform, right? And then we overlap this image over that, and we are taking the longest lines as our lanes, right? So this is important for autonomous vehicles. Now the next concept is fixed traffic light signal and counter detection. Traffic light detection and the counter value detection. Right. Okay. So why it is important? So autonomous vehicles should know that the different traffic rules. Different traffic rules, right? Basically, we are covering here the traffic lights, right? Okay. So here the methodology will be like this. So this particular framework you can see that is the input image, and we are applying that input image to a object detection model. You know object detection? Object detection models. Okay. So there are different types of object detection model like single stage detectors and two-stage detectors. Single stage, you know YOLO? Have you heard about YOLO? YOLO model. See, while we are taking our photograph, a bounding box will come, right? A bounding box will come. So how you are getting that bounding box? How you are getting that bounding box? You know, selfie. While taking a selfie, over the human face, there will be a bounding box. Correct or not? What is that box? That is given by this object detection model. It will exactly places the bounding box coordinate exactly your face. So that is an object detection model. Okay. So there are different types of object detection models like single stage and two stage. Okay. So the object detection models will start with the RCNN. RCNN. Okay. So there are different types of RCNNs. basic RCNN, fast RCNN, faster RCNN, mask RCNN, followed by, these are all two-stage detectors, followed by YOLO models. YOLO, you know YOLO? You only look once. You only look once. Okay? So YOLO different versions are there. Now it is YOLO 11. So all these are object detection models. So what it will do? What is the basic functionality of object detection? See, detect the objects. Suppose let's say, suppose in the image, what are the different objects? Object means suppose maybe humans. So object 1, object 2, object 3, object 4, object 5, like that. All these are objects. Bag, chair, everything is an object. But here, objects of interest. So what we need to identify actually? A human, an animal, or a light, or a bag. So if we train that model, so what to detect? What to detect? Right? Suppose in my application, let's say, so I want to identify a person with no helmet or triple riding. I want to identify a vehicle. I want to identify a vehicle with three humans on the bike. Right? Or a person with no helmet. What is the object? What is my objective here? To identify a vehicle, a two-wheeler with a driver, without helmet. So what I need to do? I need to train the model with what is whether the user having a helmet, driver is having a helmet or not. Right? Now, next time, if we train the model, object detection model like that, in the next step, means the testing time, it will identify whether the driver has helmet or if not, what we will do? We will develop an app. So we will give it to that traffic department, right? So that the system will identify these traffic anomalies, whether triple riding or helmetless or some slow means wheelies, stoppies. Correct. So we have to train the model such that it has to detect different types of anomalies. Right? But here what is my objective? It has to identify the traffic poles first. Traffic pole. Correct? Traffic pole is the object here. Whether there is traffic pole or not. If traffic pole, then what is the next step? What is its color? Whether red color, green color or blue color. Sorry. Orange. Red, green or orange. Then what is the next step? How much time? Timer value is also important, right? Okay? So that's why in the first step of this traffic light detection model, this model we are named it as TLSC net, traffic light signal and counter detection network. Okay? So the input image is given to a model that is RCNN, mask RCNN model. What is mask RCNN? I told you already. What is mask RCNN? Object detection model. So what are the different object detection models available? RCNN. Start with RCNN. Okay. RCNN, fast RCNN, faster RCNN, mask RCNN. Then nowadays people are using YOLO models. Okay. You only look once. 12 versions are there. YOLO V1, YOLO V2, YOLO V3. Now YOLO V11 or V11 is there. Right? So you can see here the input image is given to the mass Cartesian model. So which will identify, which will detect the object. What object here? Object of interest. What is that? Traffic light, traffic pole. Now the traffic pole will be given to again a retina net model. Retina means small. So retina net model will give us the timer value, the counter value. So we will see step by step how it will work. So object detection model we have used here is mass Cartesian. So mass Cartesian consumes the raw video frames of resolution 1920 by 1080 pixels. Raw video frame means a video consists of set of frames. Set of frames means set of images. Set of images. Correct? Okay. So the mass Cartesian will take the video frames of resolution that much, which are downscaled to 1024 and 1024 pixels, and sampled at 30 frames per second. What is 30 frames per second? 30 frames per second. That is called refresh rate. Refresh rate. So what is the minimum refresh rate is required for a video? Minimum refresh rate required for a video 24 frames per second. 24 frames per second means, see, there are only 10 frames per second. What will happen? Suppose you are watching a movie. Okay. Let's say there is 1 frame per second. What will happen? Lags. You know, in olden days, before this TVs and all those things, ఏమంటారు తెలుగులో రంగుల సినిమా ఎట్లా ప్లే చేసేవాళ్ళు తెలుసా మీకు? యు నో ఆల్ తెలుగు రైట్? సినిమాలు ఎట్లా ప్లే చేసేవాళ్ళు అంటే ఈ ఇమేజ్ పెట్టేవాళ్ళు, దాన్ని మూవ్ చేసి ఇంకో ఇమేజ్ పెట్టేవాళ్ళు. Then next image. So overall, they will show us like a movie. So like that, if there are less than 24 frames per second, the movie also looks like image. Then remove that image, place next image. Remove that image. So it will not look like continuous video. It will not look like a continuous video. So what is the minimum frames required per second? 24. That is called refresh rate of a video. So nowadays the current cameras are producing 50 frames, 60 frames per second. 50 or 60 frames per second, right? Okay. So the result, and what is the output of mass Cartesian? It will give us the object and its bounding boxes. Bounding box means, see, over the image, the box will look like over the. So suppose let's say this is head. This is head. So this bounding box is the top left coordinates and the bottom right coordinate values. Top left and bottom right coordinate values. So top left we have, bottom right we have. How to draw the bounding box then? How to draw the bounding box? Suppose if we have this coordinate value, this is x1 y1, and this coordinate value x2 y2. How to draw the bounding box? We have two coordinates. We can draw a line. Correct? You can draw a line using the slope and all those things. But how to draw the bounding box? Simple, right? So draw a horizontal line. Draw a vertical line. Draw a horizontal line. Draw a vertical line. So now this becomes bounding box. So the output of the mask Gaussian is the mask Gaussian is what? The bounding box as well as that image. So see sampled at 30 frames per second and outputs bounding boxes along with their respective masks for traffic signals. So the result of this phase is an output list with each element comprising of the top left corner and bottom right corner spatial coordinates of the bounding box and detection score. This is the thing. Then I'll also see now this is the output of the mask Gaussian. Object is detected. What is the object? Traffic light. Right? Now what is the next step? What is the next step? Counter value is important. Counter value is important. But how to get it? How to get it? Any idea? See, we need to extract only from that observed traffic light, we need to get only what? The counter value, the timer value, right? That is important. Then how to get it? Just observe that the traffic, the counter value is having different color and the background is having different color. Background is having different color. Then what method we need to do? Segmentation. That is called segmentation. So to apply segmentation, see here, color-based segmentation. Color-based segmentation, right? Now, you can see here, the background is having more black. Background is having more black. Whereas this arrow as well as the counter value is having red color, right? So now we need to do thresholding over the red color here. This is the process. This is the process here. So masking with the bitwise and. So what is the color of counter? Some red. Okay. So the remaining one we need to do multiply with the what we need to do here 34, right? And okay, right. Thresholding we need to apply the colors below. Suppose red is having some threshold, red is having some intensity, right? Red is having some intensity. Not 255, full red is 255. Complete black is 0. So let's say here the color value is 200. At all the colors below 200, convert them into 0. Write a code, short code like the color. If the color value is below 200, make it as 0. Make it as 0. If the color value is greater than 200, make it as 255, means 1. Right? So now your image becomes black and white. Correct or not? All the color intensities below 200, make them as 0. Color intensities greater than 200, make them as 1. Okay? Now this is the resultant image. This is the resultant image. So all the colors less than this particular color. Less than this particular color becomes black. Equal or less than this color, greater than this color will become white. This becomes white and remaining will become black. Now perform AND operation over, multiply these intensities. Okay. Now what is the color of this background color? Yeah, that check stand up. Checks. What is the color of that background here? Black means what is the intensity? 0. Now multiply all these pixels, right, with this image. Now this 0 is multiplied with this one. What is the resultant image? 0. Right? Now if you multiply the pixels of this digit this one. What is the intensity of this digit arrow mark? 1. That means 255. If you multiply this one with this, one with this, one. Same color you will get. So now you can see only the digits arrow mark. Arrow mark, correct? Just the under operation we are doing, right? Now this is the resultant image. Now feed this one to the retina net model. What is the purpose of retina net model? To identify the small objects. Small objects, and it is computationally it is efficient for small objects. And you can observe here what is our main purpose here. How many digits may be there here? 0 to 9. Only 0 to in any counter. What values will have? What values will have? 22, 21, 20. Like suppose if you go to a traffic light. So what is the range actually? 0 to 9 only na. Maximum what value you get? 0 to 9 numbers. ABCD is not there on the counter. Traffic light counter you have ABCDs? No. Counter value will be there. What is that value? Numerals. 20 or 15 or 45. Then the value will be decremented. But what is the range of the numeric values? 0 to 9. So the retina net now has to classify whether that is 0, R1, R2, R3, R4, R5, R6, R7, R8, R9. So 10 digits it has to classify. Correct? So that's a small model introducing here. That is retina net model which will give us the number generation. See here 44. So it will again have you can see this is 4 and this is 4. It is identified. Okay. Now what is the counter value? 44. So how much time our vehicle that is red light? How much time our vehicle has to wait? 44 seconds. Then the counter starts here and after 44 seconds our vehicle will move. Right? So the autonomous self-driving vehicle has to apply that brake that much time. It has to stop for that much time. Right? So this is traffic light detection and number generation. Now this is the final result you can see. So over this image we are applying mass car CNN. What is the output of mass car CNN? Detecting the traffic light. Then over that we are applying it is over some masking operation we are doing to generate to come up with only the counter values. Right? Then this particular values will be feed to the retina net model. Right? So retina net model will identify the numbers. The final output. The waiting timer is 44 here. So this is output of this one. Right? So this is the architecture of mass car CNN. So you can see CNNs, convolutional neural networks. You know that or not? Okay. Term you know. Right? No issue. So what I said. RCNN, fast RCNN, mass RCNN, these are two-stage detectors. Two-stage. In the first stage, they will identify the regions. Of particular objects in the image. Then in the next stage, they will give us the regression score, that is prediction score as well as whether that is traffic light or not. Means the intended object or not. That may be traffic light, that may be means bike user's helmet, or there are 3 users. Based on our application, we need to train the model. Right? Now it will give us the object class as well as a mask, a binary mask it will give. The purpose of binary mask here is means for this particular application it is not required, but one more application. Here we are going to discuss 4 different applications, right? Animal 2, this is traffic light first, then pothole, then any other vehicles on the road, that accident detection, and one more is any animals. right? So, for this particular purpose, we use mass Gaussian, but what I told, you can use any model. You can use any model. Nowadays, these YOLO models are very faster as well as efficient than these two-stage detectors. Why? They are single stage. In a single pass, for the entire image, it will identify the objects and give the particular class. But here, it will work in two stages, these particular mass Gaussian. Because we did this work in 2021. Now the YOLO models are evolved and they are more efficient than mass Gaussian. But a particular reason is there why we use mass Gaussian. So that I will tell you while we discussing animal to vehicle collision detection. Okay. Now you can see here. So this is the first phase of the phase and this is the second stage. First stage and second stage. In the first stage, we use a CNN as the backbone to extract the feature maps of that particular objects. Okay. So the CNN will give us the feature maps. Over these feature maps, we will apply a RPN, Region Proposal Network. Region Proposal Network. So the Region Proposal Network will output like what are the different regions over the objects. Okay, the particular region. Suppose there is an object, so it will identify that particular region. Suppose if that object center falls in that particular region, that will be the output of that. Now there will be this is the feature maps. We are RPN over feature maps, which will output as means the regions may be of different shapes. The regions may be of different shapes based on the object. Suppose face. Let's say the region will be like this. Suppose there is an object like vehicle, four-wheeler. The region will be rectangular. So based on the object, different regions will get. So what ROA will do, it will convert all these different shapes to a common shape. Right? So that will be fixed size feature map. Now this will be given to the fully connected layers. So which will classify as whether the object is traffic light or not with some confidence code, and as well as the mask, binary mask of that particular object. Okay. So this is the first stage and this is the second stage, right? So stage 1, you can see two networks are there. That is backbone network, that is CNN, ResNet, VGG16, or CNN, and region proposal network. So RPN is used to give region proposals and are run once per every image. And in the second stage, so the size of these proposed regions is equalized using ROA align layer, predict object classes and bounding boxes for all proposed regions. So masks are generated for each segmented object. So the same process again explained here, right? Now the next one is vehicle to animal accident detection. Vehicle to animal accident detection, right? So why this is important? In ring road it is not required, but in service roads common, right? Ring road is there for Hyderabad. What about Warangal? What about other towns and these things? Suddenly a dog will come or a cat will come. Cat okay, dog. Serious. Very important, right? If you hit a dog, then what will happen? Your vehicle may damage. Correct or not? So, as a human we can apply brakes, but what about machine? What about autonomous vehicle, right? So that's why this is important. And one more important thing, see, on the road there is an animal, but whether that animal is leaving the road or it is entering the road. How? As a human we can sense, like if its face is that side, it is moving that side. But if its face is this side, we can say it is coming as a human. But what about machine? How it distinguish whether it is moving outside the road or coming into the towards the vehicle? And at what speed it is coming? Whether there is a chance of collide or not. All these parameters are important, right? As a human, we can guess like how much speed it is coming, whether there is a chance of collide or not. But machine, right? So that's why this particular topic is very important for autonomous cars, right? So again, here what is my target? What is my object to detect first? In the previous case, what is my object? Traffic light. But here, animal. Okay. So again, what model we have to use? An object detection model. What model I use? Mass RCNN. What model you can means what are the other models available? YOLO. Right? Nowadays, other advanced models are also there like detection transformer, DET transformer. Today I shared with my students while coming from Warangal, right? There are day by day different advanced object detection models are evolving, right? So anyway, why I use mass RCNN again? Because I need to develop an overall framework for traffic light one model, for animal one model, for vehicle detection one model, for pothole detection model. Then how complex the overall framework, right? So that's why at that time my aim was to design a model overall framework, single object detection model. Single object detection model. So what are the targets here? It has to detect whether that is traffic light or animal or vehicle or pothole or simple road or human. Right? So multi-class. It has to detect these different objects. Right? So again, for animal detection, again here we are using what? Mass RCNN. So the object detection architecture we have used is mass RCNN again. So same it will take the images of that video frames. And what is the output again here? What is the output again here? The bounding box of the animal. Bounding box of the animal, right? So animals are detected from the following categories: cat, dog, horse, sheep, cow, elephant, zebra and giraffe. But in India, Indian roads, mainly cows and dogs are important, right? Cattle. Same. Lane detection is again required. Why lane detection is required? I am going in this lane. Now animal is on the same lane or at a different lane. But if it is a different lane, but first what is the important thing? Where my car, which lane my car is there? Correct? So that lane we need to identify. Then based on my lane, whether that animal position to identify using mass RCNN. Now it's motion information like whether it is coming towards the vehicle or going to the outside the road, we need to identify, right? So the first step is lane identification, right? So for lane identification, what is our algorithm? Same, that process. What is that? First we need to apply edge detection, then half transform, finally that lanes will identify. Nowadays people are using, for lane detection also, people are using deep learning algorithms. Okay, but that time use simple image processing methods like image processing techniques. Okay. Now, see, if an animal is not within the lane, we use it as the backbone for predictive feedback mechanism for approaching animals. So then animal direction is important. Correct? Animal direction is important and the vicinity tracking is important. So there is an algorithm called centroid tracking algorithm. You can write it. Centroid tracking algorithm. So we use the centroid tracking algorithm in this case, but one more efficient method is there, which you can apply deep sort algorithm. Deep sort. DEP-SWOT, deep sort algorithm, right? Again, this centroid tracking is based on image processing. But deep sort is already trained model. Deep sort is a deep learning model. right? So animals are tracked using centroid tracking algorithm. If an animal is outside the lane, but moving towards it, we can alert the autonomous vehicle beforehand using the predictive feedback. Correct or not? The animal is outside the lane, but moving towards our lane. Moving towards our lane, so we can alert the intelligent system that the animal is coming fastly and there is a chance of hitting with 100%. Right? So, using that predictive feedback mechanism based on the following two conditions, the animal is outside the predictive lane and is moving in the direction towards it. And the animal is in the vicinity of the autonomous vehicle, right? So, this is centroid tracking algorithm, but I will not get it. Okay, I will show you an example. Yeah, this is centroid tracking algorithm. Let's say, see, my vehicle is going in this lane. Yeah, please, if you listen, I will explain. Otherwise, waste of my energy and all these things. Right? So, let's say, a video with set of frames. In the first frame, that animal is identified at position x1, y1. Its center is x1, y1. Its center is x1, y1. In the next frame, that center is, animal center is x2, y2. What is animal center there? We have bounding boxes, right? Based on bounding boxes, now we can identify the center of the image. This is the center of the image, correct? So, in the first frame, the animal is at x1, y1. Next frame, the animal is x2, y2. Next frame, it is x3, y3. Next frame, x4, y4. So, now we have how many frames per second, correct or not? We have the refresh rate of the video. Now, based on this x1, y1, x2, y2, x3, y3, now we have to find out the distance of these values with our vehicle. As the animal is approaching towards the vehicle, the distance will reduce. But if the animal is going outside the lane, what will happen? From x1 to x2, y2, if it is moved, the x2, y2 distance will be more than x1, y1. Based on that, we can say that animal is moving outside the lane. So, based on this information, the centroid tracking algorithm will work. So, you know Euclidean distance, right? x2 minus x1 plus y2 minus y1 square root. Euclidean distance. Based on that information, you can get to know whether it is approaching or leaving the lane, right? So, this is the predictive feedback mechanism. Now you can see animal detected at the beginning of the feed. See that bounding box, our vehicle is there. We detected the lane. It is the animal is here. Now how to find out whether it is in the vicinity of the vehicle or not? So over this road, what we will do? We'll draw a horizontal line. We'll draw a horizontal line. Now, over the horizontal line, we'll draw a perpendicular line. Now, if this vehicle is, this animal is, within that, suppose if it is falls like in the left half of the perpendicular line, we can say that is in the vicinity of the vehicle. So, now you can see here. See, this is the horizontal line. Are you getting or not? This is the horizontal line. And if we track it, if you draw a vertical line, you can see it is in the vicinity of the vehicle. So, indication is stop. But here, if you observe, if you draw a horizontal line, the perpendicular line will be like this. So, it is the second half of the perpendicular line. So that's why here just indication is go, but here the indication is stop, right? So like that this predictive mechanism will work. So then this combination of the two stages yes, the road is unobstructed, we give a go signal to the autonomous vehicle. If an animal is present within the lanes or near the lanes, as per the predictive feedback mechanism, we give a stop signal to the vehicle. Right? Not we will not give. Right? The autonomous system, like the predictive mechanism will give a signal. You have to wait. Means it has to apply the brake. Right? Now the next method is vehicular accident detection. Vehicular accident detection. So is there any chance of accident with our vehicle or any accident happened in front of this particular vehicle? So how to identify? Suppose let's say again my self-driving car is going in this lane. Now I need to know whether any accident happened or there or not. Now tell me, if an accident happens, there is a chance of two vehicles will collide. Correct or not? Two vehicles will collide and their speed is if both collide already means there is a collision between two vehicles, some accident happened, two or three vehicles accident happened, then what is the speed of that vehicle accidented means collided vehicles? 0. So that is an indicator. That is an indicator. The first step again is to detect the vehicle on the road. Vehicle on the road. Again what model you have to use? Mass car CNN. But any model I told you, because we use mass car CNN, but you can apply any model. Right? Don't forget. Okay? Don't mass car CNN. Right? Again, mass car CNN we use here for vehicular detection. Okay. Now, the steps, the procedure for vehicular accident detection is first thing is vehicle detection using mass car CNN, then vehicle tracking, right? Then vehicle overlap. Is there any overlap of multiple vehicles? So here the mass car CNN will help us. So no other object detection models will be efficient for this particular work. Because to detect an accident, there should be multiple vehicle overlap will be there. Correct or not? The masks. So the mass car CNN is giving along with the object, is also giving a mask. Okay? Now there is a collision between the vehicles. Their masks will overlap. No, just I know you. The IOU of the both masks is greater than 0.5 or some predefined code. And their speed is 0. And their speed is 0. You can predict as there is an accident happened between multiple vehicles. Now again, what is the indication for? What is the indication you need to give? Stop your vehicle or reduce the speed. Reduce the speed. Right? So this is the thing. Here it will follow. Right? Again, lane detection is compulsory, correct? Lane detection is required. Required or not? Because on which lane it is there? Suppose this lane is completely free. Accident happened 4th lane. What is the need to stop? Correct? So again lane detection is important. So lane detection and section-wise analysis. So vehicle trajectory and angle of intersection determination. Vehicle speed and change in acceleration is detection. And finally accident detection. This we'll see one by one. Mass car CNN. Okay, vehicle detection will be done by mass car CNN, right? Then vehicle tracking using centroid tracking algorithm, right? Then vehicle overlap. This is important. See, in any vehicular accident, the two vehicles must collide. So this means that in an instance, these two vehicles must be overlapping in a frame. Correct assumption or not? Correct assumption or not? Again, ask you to stand one time, but still you are continuing. Huh? See, I am wasting a lot of energy. Correct or not? You are sad like. You can bring some water. Go and bring some water. Huh? Go. Some water I need. You just go and bring some water. Huh? Okay, fine. To turn your attention for some time. Huh? Correct? Right. So, vehicle overlap. So, how to do vehicle overlap? So, we require mass here. They take mass by mass. So, there is an overlap of greater than some threshold between those taking mass. So, that is an accident. But which object detection will give us mass? Which object detection will give us mass? So, mass RCNN. See, simple RCNN is there. What I told, RCNN is there, fast RCNN is there, faster RCNN is there. They all give the classification, object classification and its code. But additionally, what mass RCNN is giving? The mass. So, which is helping us to predict the vehicle overlap during the accident. Vehicle overlap during the accident. So that's why we use mass RCNN collectively for all these frameworks. Okay, that is the reason. Right. Oh, battery running low. Give it. Okay. Then lane detection followed by section-wise analysis. So you can see here the lane detection and section-wise analysis. You can see. So S1, S2 and S3. This is section-wise analysis. So S2 is within that particular vehicle's lane. So between both of the lane demarcations, and S1 is left side of the left lane demarcation, and S3 is right side of the right lane demarcation. That is, this is right side, this is left side, and it is within the lane. Means that detected vehicles with how much overlap? Greater than 0.5 overlap between mass. Okay, means the threshold we are taking. Based on that, we are doing this section-wise analysis. Right. Now then vehicle speed. What about the speed? Acceleration is determined in a series of steps by determining factors such as interval between the frames, gross speed, and some formula we applied here. But I removed that formula because it's difficult to. Okay. Then score detection. Anomaly scores each parameter aggregated through a function of alpha, beta, gamma, which we calculated in the previous. But I removed that. Okay. Which takes into account the weightages of the individual thresholds and generate a score between 0 and 1. A score which is greater than 0.5 is considered as a vehicle accident, else it is discarded. Right? So this is the process. So here some score it is calculated because it is left side of the left lane and so the alert is go, but here you can see based on the speed and section-wise analysis, these two vehicles speed is 0 as well as they are within the lane of that particular vehicle, right? So that's why issued a stop alert. The last one is pothole detection. pothole detection. So this is very common. Again, what we use here, mass car CNN. Okay, right. But whatever the data set we got is having only 431 images that time. 431. But you know, deep learning models are data hungry. What is the meaning of data hungry? They require more data. More data. But they have only 431 images. So what we need to do? We need to do data augmentation. So annotation is okay, but annotation is the purpose of annotation is see here the images are there, correct? Now what is this? It is a pothole. It is a potholes. So we got the raw images actually. Raw images means so for training the model, deep learning model, we need to say what is a deep learning model actually. There are different types of models. Supervised learning, unsupervised learning. So what is supervised? Labeled data. What is meant by labeled? So at the time of training, we'll inform the model that this is a human. This is a bag. This is a mic. Correct or not? Yes. So that is called labeling. Otherwise, any model, any AI model is like a newborn baby. Hello please. Any AI model is basically without training is like a LKG student or nursery student. So nursery student knows anything in the first day, but what teacher will do? He will train him. He will train him. So after coming to first class or second class, he will train with some additions, multiplications, like that. So without training, he will know whether how to do addition. He will know or not. Without training, a second class student will do addition. No. Likewise, thank you. Likewise, an AI model also, without training, it is like a student. It is like a newborn baby, right? So it requires training. So for the newborn baby also, in his third month or fourth month, what is his parents, what they will do? Beta, this is a ball. Beta, this is ball. This is pen. Correct or not? Correct or not? So proper training is required. Proper training is required. Otherwise, suppose if he lives in a forest without parents, without nothing, so he doesn't know anything. Shivaputrudu movie. You saw Shivaputrudu movie? Shivaputrudu. Aparichitudu. Hero. Aparichitudu. Vikram. So see Shivaputrudu movie. In that, he never enters in the village. He will be at the, what is that? What is that? Graveyard. Right? So once he enters the village, but he won't do anything. He behaves like an animal. So because proper training was not there. So like that, even the machine learning or AI model, basically it is like a kid. It is like a kid, right? So if we train him properly, so he will be trained and he can do the predictions next time. Right? Like suppose in your class, your faculty will teach you some examples, mathematical examples, and he will give some assignment. Why the assignment is required? Whether you trained properly or not. Whether you trained properly or not. Right? So if you are able to do the assignment in the assignment, so he will get to know that you are trained properly. Otherwise, you need more training. You need more training. Right? So that's why in the class also the faculty will give suitable examples and give the assignment. So likewise the AI model also require huge amount of data, huge amount of examples, right? For training purpose. So that's why how we are training the student or a kid for the machine learning or AI model also, we need to train like what exactly this is. Whether there is a ball or whether there is a pen, whether there is a laptop, whether there is a traffic light, whether there is an animal, whether there is a vehicle in our case. So like that, we need to train. So that's why here part goals. We need to do the annotations. Whether there is a part goal or not. Right? So that process will do the annotation. Right? Then we'll do the data set augmentation because we have only 431 images. So data augmentation involves here one image that will be flipped to become another image. It will be rotated a little bit. It will be scaled. Our duplicate image will be generated. Nowadays people are using AI tools for data augmentation. What is augmentation? Create more samples of the same image. More samples of the same image. My same image is there. Rotate it, flip it, scale it, zoom out, zoom in. So different geometric operations, transformations we can apply to make more images of the single image. So like that we did from 431 generated 9416. Out of that we used 9000 for training or 460 images for testing. Right? Then model is CNN to train the model. But here there are two classes. Whether there is a background, that means whether there is a road or a part hole. Right? So that will be trained. And so these are the few results of all these models. So this is operating system environment. Use TensorFlow and our GPU, NVIDIA Tesla K8 GPU. And these are the measures we taken. Precision recall and average precision. Detection ratio and false alarm ratio. What is false alarm? What is false alarm? Wrong assumption. False alarm. Right? So there is a part goal, but system will say that is not a part goal. Right? That is a traffic light. But system is that is not at all a traffic light. But system may sometimes mistakenly this particular thing. See, this is similar to traffic light, right? So the system may, if it was not trained properly, it may do the mistake, like your assignment. Okay? If you are not trained properly, so your assignment will not do the assignment. But if you train properly, you can finish the assignment. Yeah, I am observing. So I'll ask you to stand up, then your faculty will check and they will reduce your internal marks. Okay? That's why keep calm. Right, no problem. This is required, but sometimes. Always you laugh, then your life also will be. Don't do like that. Right? So there are a few traffic light detection and timer inscription. So precision is 82% time. And the recall is 86%. Average precision is. So you know confusion matrix? You know confusion matrix? True positives versus true negatives, false positives and false negatives. So true positive is the object is that is a traffic light, and the system will say that it is a traffic light. That is true positive. True negative is that is not a traffic light. The system will say that is not a traffic light. Negative class. truly it is saying, not a traffic light, not a traffic light. Okay, that is false, and the system also saying that is false. That is true negative. What is false positive? Falsely the system is saying that is not a traffic light, but system is rendered as traffic light. That is not actually traffic light. Falsely positive, false negative. That is traffic light, but system is saying that is not traffic light. Right? So based on that values, we need to find out this precision. The formula is, true positives versus true positives plus false positives. We call true positives versus true positives plus false negatives. Right? These are the results and success rate of the timer detection, 95%. What model we use for timer detection? Mask RCN for traffic light detection. Timer detection values. Retina net is efficient for small objects. And this is a precision and recall curve for traffic lights. And this is a digit recognition, individual digit recognition. So we have here 10 classes, that is 0 to 9. So how much accurately 0 is recognized by the retina net model, right? So average precision is 83, for 1 it is 80. So for 3 and 8 there will be a confusion. 3 and 8, see here, because always on the image, the images will not be that much high resolution. So the system will predict sometimes 3 as 8, 8 as 3. So you can see here, for 3 the precision is 70%. For 8 also it is 77%. Right? It will be low. Wrong predictions will happen. Okay. So this is the results of thing. And by that time, only one work was there for counter detection. Traffic light it is okay, but counter detection. So it was experimented with this particular model because you need to prove while doing any project, you need to prove your model is efficient. Your model is more accurate than other models. Because see, there will be always there is a solution for any problem. But your solution should be more efficient. Okay. From Warangal to Hyderabad already an existing road is there. But why you need to have another four lanes? Why it is required? Or why another way of transportation is required? To reduce the time. It happened. To reduce the time, right? So reduce the time or cost or something. So always you need to concentrate on some measure which will make your model efficient, right? So here at that time it was there 98%, but only thing this particular method they applied for simple counters, right? But our model we experimented on traffic light counter values. So that's why anyway, the precision is lesser only. Still we compared and published this work. Okay. Now, vehicle to annual accident detection, these are the precision recall values. You can see 86%, at IOU 0.5, and for cows, and for dogs, precision is 86 for cows and 84 for dogs. Right? So again comparative study, here our model is a little bit better. You can see here, potential accident detection ratio. So detected potential accident cases versus total positive cases. So 100 accidents actually happened. Our model predicted 82 times correctly. 84 times correctly. Out of 100. What is meant by 84%? Out of 100, 84 times the model was predicted correctly. Right? So this is other methods, 2.50. Now FAR, what is FAR? False acceptance rate. Falsely detected is 0.08 times. Other model, but ours is 0.02. Vehicle accident detection. Again, this is 77.05. average detection ratio. So false acceptance is 34%. Compared to others, it is less, right? So pothole detection, again precision 89%, recall 85, and other previous approaches. But there are, see, YOLO V2, that time it was there. See here, LK song and all, YOLO V2 they used 60%. But ours is 89% on the same data set. So this data set is also available on Kaggle. Kaggle, you know Kaggle? How many of you know Kaggle? Kaggle site. You can get many data sets and many existing works. From where you can get the code, open source code you will get, and you can experiment on the given data set. Okay, you can practice, you can use that code, and you can customize that code based on your requirement. So in our days, to do the project, people will generally go to MeitY or Dilshanagar. Our time is Dilshanagar. You know Dilshanagar? If you give 1,000 or 2,000 rupees, they will hand over a project with what? Report. But now, there is no need to go to MeitY or Dilshanagar. You can get the codes from Kaggle and data sets also from Kaggle or other websites like papers with code. So you can get the papers as well as their code and data sets. You can use your Google Colab. You know Colab? Google Colab. Like our Google Drive, Gmail. So that Google Colab also will be there, right? You can use it. You can use that code and you can experiment. You can get the result. And what Kaggle, papers with code, and one more will be there. What is that? What is that? GitHub. In GitHub also you get these type of problem statements like related to medical imaging, related to different problems, image processing or other areas also, and then report based on your observations and problem statement. You can write the report and you can save 10,000 or 5,000 for your father, right? Okay. So any questions, please? Any questions? So how you can improvise this? How you can improvise this? So currently I am also working on these traffic anomalies. What I told, like helmetless driving, triple riding, wheelies, stoppies, wrong way, wrong parking, wrong U-turn. See, if we club all these anomalies into a single framework, it will be good, right? It will be good or right? Good or not? So nowadays, everywhere surveillance cameras are there. Surveillance cameras are there. So if we feed the data to an intelligent system, so that system itself will detect anomalies, violations, right? So no human intervention is required. Right? So this traffic police and analyzing that videos, watching that videos for anomalies by the human operator is not required. The system itself will do. Right? So any questions, please? So other method is also there. Other work also we did like traffic signs. But here we haven't covered because that model is different. Means one of my BTech students did that work like using simple CNN model. For classifying different traffic signs. Right? So and all these works are published in reputed. Any questions please ask. So you need punishment, right? You need punishment or you? Right? Hello, please. So all these works are published like the conferences, computer vision and image processing. That is a top conference in India related to image processing. See this? Yeah. You can see this deep learning based pothole detection for intelligent transport systems. So published in conference 23rd International Conference on NIT NIT Silchar. Then see this traffic signal and counter timer detection network for autonomous vehicles. So this is International Journal of Computer and so this is a journal published in MITY Labs, USA. Machine Intelligence Laboratory, Research Laboratory. And the next one, real-time traffic sign recognition and classification, but this used CNN. And computer vision-based accident detection for autonomous vehicles. Conference Indicon. This is a top one, Taiwan conference in India. Indicon, right? And one more. Yes, computer vision based pollution avoidance framework for autonomous vehicles, CVIP, right? So all these 4 works or 5 works are published, right? So if you have any questions, please ask.